Today's video, we're gonna learn how to solve the sides of a right triangle. So, what is a right triangle? A right triangle is a triangle in which one angle is a right angle. These are the things you need to know about right triangle. So here's an example of a right triangle. The longest side of a right triangle is called the hypotenuse. And the side in which the angle theta is facing is called the opposite. And the base of that angle is called the adjacent. And one of its angle is fixed at 90 degrees. And the formula that is used to solve the sides of a right triangle is the Pythagorean theorem, which states that a squared plus b squared is equals to c squared. The a and b represents either the opposite or the adjacent, but the c represents the hypotenuse. So let's try some examples. Given a right triangle with an adjacent of 8 and an opposite of 5 with an unknown hypotenuse. So let's try to solve for the hypotenuse using the Pythagorean theorem of a squared plus b squared is equals to c squared. A and b can either be the adjacent or the opposite, but in this case, let's make A the adjacent and B the opposite. To solve for C or the hypotenuse, we first need to eliminate the exponent by finding the square root. So the square root of C squared is equals to the square root of 8 squared plus 5 squared. Therefore, the answer will be 9.43. Let's try another example. A given right triangle with an hypotenuse of 7 and an adjacent of 4. Let's make A as the adjacent and B the opposite. And C is equals to 7 squared. To solve for B, we need to transfer 4 squared to the right side, which will become negative. And let's find the square root of both sides. The answer will be 5.74. Let's try another example. A given right triangle with an hypotenuse of 8 and an opposite of 5. Try to find the adjacent. You can pause the video to solve this one. Let us make A the adjacent and B the opposite. To solve for A, we need to transfer 5 squared to the right, which will become negative 5 squared. Take the square root of both sides. And A will be equal to 6.24. This time, let's try to solve a right triangle with a given of only one side and an angle. So given in the first triangle of 9 as the hypotenuse and y as the opposite and x as the adjacent, measuring an angle of 30 degrees, and the second triangle with the hypotenuse W and the adjacent Z. In solving these triangles, we need to take note of the mnemonic SOHCAHTOA. So the SO represents sine theta is equal to opposite over hypotenuse, and the Ka represents cosine theta is equal to adjacent over hypotenuse, and the TOA represents tangent theta is equal to opposite over adjacent. So let's first solve the first triangle. Starting from x, the x is the adjacent and the 9 is the hypotenuse. So therefore, we're gonna use the ka, which is cosine theta, which is 30, is equals to the adjacent x over the hypotenuse 9. So all we're gonna do is to cross multiply the 9 to the cosine 30, therefore it will become 9 cosine 30 is equals to x. Therefore, x is equals to 7.79. Let's write on the x. And the next thing that we're gonna solve is the y. Since there's only one missing side in the first triangle, we can now use the Pythagorean theorem. So there's two methods to solve this one. First is the method we've used earlier, and the second one is the Pythagorean theorem. So I'll show you how to solve both of them. Let's try the Pythagorean theorem. A squared plus b squared is equals to c squared. So a, in this case, let's make a the x, which is 7.79, plus b squared, which is missing, and equals to the hypotenuse 9. Let us transpose the x to the other side, which will become negative. So the equation will be b squared is equals to 9 squared minus 7.79 squared. Then you find the square root of both terms. Therefore, b will be equal to 4.5. Let's try the other method. So this method is only applicable when there's one side and an angle given. We can either use the SOH and the TOA, since we have the values for the adjacent and the hypotenuse. So in this case, let's try to use the TOA. So tangent theta, which is 30, is equals to the opposite y over the adjacent x, which is 7.79. Then you cross multiply 7.79 to tangent 30, therefore it will become 7.79 tangent 30 is equals to y. Therefore, y is equals to 4.5. And we got the same answer. So for the next triangle, let's try to solve for the w. Since we have the value for the opposite, which is y, and we're gonna find the w, which is the hypotenuse, therefore, we're gonna use the SOH, which is sine theta, which is 60, is equals to the opposite y over the hypotenuse w. Since the w is a denominator, to solve for w, we need to cross multiply the w to the numerator, and also to cross multiply the sine 60 to the denominator. Therefore, it will become w is equals to 4.5 divided by sine 60 degrees. Therefore, w is equal to 5.2. Since we have the value of the opposite and the hypotenuse, we can either use the ka and TOA. But in this case, let's try to use the ka. So cosine theta, which is 60 degrees, is equal to z, which is the adjacent, over 5.2, which is the hypotenuse w. So to solve for z, we need to cross multiply the 5.2 to the cosine 60 degrees. So therefore, it will become 5.2 cosine 60 degrees is equal to z. Therefore, z is equal to 2.6. And that's how you can solve the sides of a right triangle.